So now we're going to simplify radicals, and this is going to be some old, some new, right? So square root of 72, you've done a million times, where you simplify by saying what's the biggest perfect square that goes into 72, and it's 36, and it's 6 root 2, and then other people say, well, what about 9 and 8? And we say, okay, you can do 9 and 8, but then you're going to have to do it again, because square root of 8 is square root of 4, square root of 2, and the square root of 4 is 2, and then you just kind of made more work for yourself. So it's easier to do the biggest perfect square. But now we're going to introduce variables. So if I have the square root of 9x squared, what do you think that's going to be? Everybody says 3x, right? But it's actually 3 times the absolute value of x. What? Absolute value bars are needed whenever you take an even root of a variable. Even root being square root, fourth root, sixth root. Why do we need it? It's like a whole thing, right? So the square root of x squared, you might say, well, that's just x, but it's the square root of x because if x is 3, you get the square root of 3 squared, which is the square root of 9, which is 3. But if x is negative 3, you get the square root of negative 3 squared, which is the square root of 9, which is 3, which is not equal to your original x of negative 3, right? So that's why it's the absolute value of the x. Okay? Or you could just be like, she's not lying to us, it's the absolute value. In number 3, we're going to factor that first, so it's the square root of x plus 2 squared, which since it has a variable in it and it's an even root, is going to be the absolute value of x plus 2. Square root of 625 is 25. It's an absolute value problem, x cubed y. You don't have to put the absolute value bars around the number, just around the variables. Absolute value of x to the fourth is going to be, or the square root of x to the fourth is going to be the absolute value of x squared. Number 6 is the first one where it's not a perfect square, right? So, there's a few ways to think of it. One way is to think of it as 5 x's. Every time you get a pair of x's, you can take one out. So the square root of x to the fifth is x squared root x. And we're going to have bars around the x squareds. Or another way to think of it is like a baby 2 for the square root, and 2 goes into 5 twice with 1 left over. Square root of x to the 100th, everybody thinks is x to the 10th, but it's not. It's x to the 50th. Why x to the 50th? Why not x to the 10th? Well, what's x to the 10th times x to the 10th? All right, add the powers, x to the 20th, not x to the 100th. X to the 50 times x to the 50 is x to the 100, because when you multiply, you add the powers. Back with the variables, sometimes putting a little baby 2 there can help. 2 goes into 7 3 times with 1 left over, and 2 goes into 8 4 times. Bars around the variables. Square roots of variables get bars. Whew, okay, so then we switch to cube roots for a while. You see a couple rows here, cube roots. So cube roots, I can take the cube roots of negatives, right? Well, first of all, let's do this one. So the cube root of 48, people think like, oh, 8 times 6. It's going to be 16 times 3. Wait, sorry, it is going to be 8 times 6. Square root is 16 times 3. I'm getting confused. It is 8 and 6 because 8 is a perfect cube. The cube root of 8 is 2, and the cube root of 6 we don't know. Same thing with cube root of 24, cube root of 8, cube root of 3. The cube root of 8 is 2, the cube root of 3 we don't know. 54, not going to do 9 and 6, rather 27 and 2. The cube root of 27 is 3, the cube root of 2 we don't know. Cube root of 27, C9, 3, y to the 15th. So the cube root of 27 is 3. The cube root of c to the 9th, 3 goes into 9 3 times. 3 goes into 15 5 times. No bars are needed because it's a cube root. It's not an even root. That's an odd root. And the reason for that is because you can take the cube roots of negative numbers. Right? The cube root of negative 8 is negative 2. Now I don't have enough to take out any variables, so those stay inside. Cube root of 3c plus 2 cubed is 3c plus 2. Cube root of x to the 4th, 3 goes into 4 once with 1 left over. 3 goes into 5 once with 2 left over. And don't forget that little baby 3 there in the answer. That's important. People forget that sometimes. Cube root of x to the 12th, 3 goes into 12 4 times. 3 goes into 13 4 times, but I have 1 left over. And again, that little cube root is important. So every problem's like a little bit different. The next chunk here, oh, there's lots to go here. Yikes. Okay, so here I'm going to multiply. 3 times 4 is 12. Root 2 times root 8 is root 16. 12 times 4, 48. You've done those problems before. A cube root just kind of follows suit here, where you would multiply it together. Cube root of 48, well, we just talked about that. Cube root of 8, cube root of 6, cube root of 8 is 2, cube root of 6, I don't know. Here I'm going to multiply these together. Square root of x to the 9th, y to the 6th, because when I multiply, I add the powers. Understood baby 2 there. 2 goes into 9 4 times with 1 left over, and 2 goes into 6 3 times. Because it's an even root of a variable, I add my bars. Fourth roots, we haven't really seen a fourth root yet. Fourth root of 16 n to the 8th. Do you know the fourth root of 16? Yep, it's 2. And then the fourth root of n to the 8th is n squared. Because it's got an even root of a variable, I add the bars. Fourth root of x to the 4th is x. Fourth root of y to the 7th would go in once, but I'd have a leftover y cubed. And again, bars, even root of a variable. A fifth root. Do you know that the fifth root of 32 is 2? That 2 to the 5th is 32, and then x squared, 5 goes into 10 twice. No bars needed because it's an odd root. People will always say, when are the bars needed? When are the bars needed? Even roots of variables. So 32 here is 2 to the 5th, so I'm just going to rewrite it there. And then that can be treated as a variable. 4 goes into 5 once with 1 left over. X cubed, not enough to take 1 out, and then 4 goes into 4 once, and then I get bars. The sixth root of 64 is 2. Sixth root of c12 will be c squared, and then I can pull out an a. That again is an even root, the sixth root, and I'm left with the sixth root of a. So I know it's a lot of examples, but hopefully that helps clarify it. The last couple rows here, right? Here adding, so I have to simplify 6 root 12. Root 12, remember, is root 4 root 3 or 2 root 3. And so, it's not letting me write the 2. 6 times 2 is 12 root 3. And then those can add up. So you first have to simplify so that you get like terms. 3 root 2, 108. Isn't 108 like 36 and 3? So I believe that's 6 root 3. And then 5 root 2, of course. Those are the only like terms. 8 root 2 minus 6 root 3. Here these are like terms. 1 cube root of 3, 4 cube roots of 3. I get 5 cube roots of 3. Cube root of 48, we did a few times up there. Cube root of 8, cube root of 6, so 2 cube root of 6 minus essentially 1 cube root of 6 is just going to leave us with 1 cube root of 6. Finally, the last thing here. Okay, so the last thing is dividing or rationalizing denominators. You have done this before with square roots almost till you're blue in the face. Like, you've done this about 8 million times, right? 3 root 7 over 7. But if we look at what we did, I always ask, how many do I need? How many do I have? How many more do I need? So when it's a square root, that means I need 2 7s to take 1 out. I have 1 7, so I needed another one. In other words, I needed this to become the square root of 7 squared, so it could become 7. If it's a cube root here, that means I need 3 7s, and I only have 1. So how many more do I need? Right, I need 2. So I'm going to multiply top and bottom by the cube root of 7 squared. This gives me in the top the cube root of 49, and in the bottom now I have 7 because cube root of 7 cubed times the cube root of 7 squared, or cube root of 7 times the cube root of 7 squared is the cube root of 7 cubed, which is 7. No need to multiply that out. Now we go up to a fourth root. The fourth root is needing 4. I have 1. How many more do I need? 3. So I'm going to multiply top and bottom, and you have to show this work by the fourth root of 7 cubed. And I'm not going to even look up what 7 cubed is. You can just leave it like that. The bottom, again, is going to be 7. Why? When I multiply those together, I get the fourth root of 7 to the fourth, which is 7. Once you get it, but it takes sometimes a little bit. There's a little bit of a different shake on it, a fifth root, but notice that we had 2 7s to start. So if I need 5 and I have 2, how many more do I need? Right, I need 3 more. Oops, doesn't like that. 3 more. So I'm going to multiply top and bottom by the fifth root of 7 cubed. So I'm going to get as my answer, fifth root of 7 cubed, I can leave it like that, over 7. The reason the denominator is 7 is because when I multiply those together, I get the fifth root of 7 to the fifth, which is 7. So I know that that last row is tricky. There are questions like that on the quiz or on the test, so you definitely need to know it. And I know that was a lot of info on simplifying radicals.